Hi guys, just a quick lesson on exponential equations. So the idea is that you will have the exponent again will be the variable and you're trying to solve for that exponent, okay? So we're trying to work out what the variable is equal to. So the idea is you make the base on both sides the same and therefore you can equate the indices and therefore solving the resulting equation. Okay, so if I had really quickly, just a quick example, if I had 3x was equal to 3 to the power of 3, then I could therefore say that x is equal to 3 because they have to be equal. Okay, so for my next example, a little bit more complicated. So 3 to the power of 2x minus 5 is equal to 3 to the power of x plus 3. So because their base is the same, since their bases are the same, we simply let the exponents be equal to each other also. Okay, so if 3 to the power of 2x minus 5 is equal to 3 to the power of x plus 3, then this would imply that 2x minus 5 is equal to x plus 3, and then you just solve for the x's. So 2x, take x, is equal to 3 plus 5, collecting my like terms on one side, x is on one side, numbers on the other, so x is equal to 8, okay? For the next one, looks a little bit more complicated, but it shouldn't be. So again, if my bases are the same, I can let my exponents be the same. So 3x minus 1 is equal to 1/3 x plus 5. Collect all my x's, so 3x take, when I bring over my positive third, it becomes take third. X equals 5, bring over my negative 1, it becomes plus 1. So 3 is the same as 9/3, so 9/3 take away 1/3 is 8/3. X is equal to 6. And from there I can bring over my divide by 3 and it will become times by 3, so 8x is equal to 6 times 3 is 18, so x is equal to, again, times 8, so when I bring it over it becomes divide 8, so 18 divided by 8, which we know is equal to 2 1/4. So x is equal to 2 1/4 in that exponential equation. Okay, starting to get onto a little bit trickier. So for this one, we've already practiced with different bases, so we now just need to apply that rule. So I've got 3 on one side and 27 on the other, but I know that 27 can be written as a base of 3 as well. So first step is write them as the same base. So 3 to the power of 2x plus 3 is equal to, 27 can be rewritten as 3 to the 3, all to the power of x minus 1. So I end up with 3 to the power of 2x plus 3 is equal to 3 to the power of 3x minus 3. And then my base is the same, so I can now let them equal to each other. So 2x plus 3 is equal to 3x minus 3. Bring my 3x over, it becomes take, so 2x take 3x is equal to, my negative 3 stays where it is, this plus 3 comes over, becomes negative 3 as well, so I get negative x is equal to negative 6, so therefore x is equal to just 6. Okay, and I've solved my variable x. Okay, with example 4, 16 to the power of x plus 1 is equal to 1/32. So again, I'm looking for a common base. Better off going with the prime bases. So 16 I know can be written as a base of 2, and so can 32. So 16 is 2 to the power of 4, all to the power of x plus 1. And I know that 1/32 can be written as 2 to the 5. Okay? Now I don't like having that 2 to the 5 underneath, so when I bring the 2 to the positive 5 up, it becomes 2 to the negative 5s. And on this side, my left hand side, I have 4 times x, which is 4x, and 4 times positive 1, which is plus 4. Equals, again, I've just talked about that, bringing my 2 to the power of 5 up, so it'll become negative 5. So 2 to the power of negative 5. And now I have my bases are the same on both sides too, so I can therefore say that 4x plus 4 is equal to negative 5. So 4x is equal to negative 5. Bring my plus 4 over, becomes take 4, so 4x is equal to negative 9. So x is equal to negative 9 divided by 4, which is also equal to negative 2 1/4. So x is negative 2 1/4, negative 2 and 2.25, whatever you want to write this. Okay. Last example, a little bit more complex again. I've got 16 and 16 to the power of x minus 5 times 2 to the power of x minus 24. Okay, so what I'm going to do is I'm going to write them with a common base. My 16 I can rewrite as 4 squared. Now again, we've been looking for prime factors, but what I want to actually break this up into is a trinomial. So instead of going to the base, I'm going to just do 4 squared. Okay, because the 4 squared then will give me a squared term at the front, and then I will have a non-square term in the middle and a constant term, so I'm actually going to end up with a trinomial. So again, this is all about practice and actually spotting these. So if I say 4 squared to the x is going to be just 4 to the 2x minus 5 times 4x minus 24 equals 0. Okay, and just thinking about that now, guys, okay, I've got here, I can rewrite that as 4 to the x all squared, and here I've got a 4 to the x as well. Okay, so what I can do is I can let my 4 to the x equal to, we'll take a different letter, so we'll take y. So for 4 to the 2x, I'm going to have y squared minus 5, my 4x becomes y, minus 24 equals 0. Okay, I can solve my trinomial, open up my brackets, y and y, 8 and 3 for my factors of 24 to give me 5. Last sign's negative, they're both going to be different. Bigger one has to be negative because I want negative 5, so that's plus 3 equals 0. And now I know my y is 4x, so it's going to be, in this first factor, y plus 3, it's going to be y is equal to negative 3. So 4 to the x is equal to negative 3. And for this one, y is equal to 8. So it's going to be 4 to the x is equal to 8. And I know that 4 to the power of x is equal to negative 3 doesn't have any solutions, so I can put a line through that and just ignore that one. But 4 to the x is equal to 8, I can rewrite the 4 as 2, sorry, you probably can't see that green, do it in blue. So 2 to the power of 2x is equal to, and we know that 8 can be written as 2 cubed, and then because my base is the same, I can therefore say that 2x is equal to 3, which means that x is equal to 3 divided by 2, or x is equal to 1.5. And that's it, you're done, or 1.5. Okay, so that's as complicated as we're going to get, the trinomials, so just look out for them. Okay, and again, that'll just be with practice. Okay, thanks guys.